evening, everyone. Welcome to Data Analytics Colloquium 2022. This is the inaugural event, inaugural speech for this season 2022. And on the screen with me is Dr. Peter Pan, Pan Jin Han, Professor Pan Jin Han, and from the National Chongqing University in Taichung. And in a little bit, I will let him introduce himself and also introduce to the attendees and the members and students and other friends in Taichung. And also tonight, let me briefly introduce Dr. Wlezien from University of Texas at Austin will be our inaugural speaker. And I think I should give him a big round of applause. And how do I do that in here? And I think we can do something like that. So particularly, I want to thank everyone, including the speakers, the patience with us for the really technically challenging startup. All right, and Dr. Pan, would you like to introduce a colloquium and also to our students, to students in Taiwan, and yeah, etc. Yeah, Dr.
Okay,
Pan.
thank you. Yeah, thank you. Can you hear me?
Yes.
All right, good. Finally. All right. I thought we were in a parallel universe or something, multi-universe situation. Okay. So, Dr. Wlezien, thank you for coming aboard, and all the audience. Welcome to Data Analytics Colloquium. Let me just briefly introduce this to you if you're first time on board with us. This colloquium is set up like 2 years ago. This is the third year that we have the series now, and it's an initiative that, well, actually, I would say the car initiate this colloquium, and then we think this is a very good idea that we can share the up to date methods, research methods in the political science and policy and public administration, things like that. So we have invited quite a few very important and well-known scholars to give a speech or a webinar online. And you can check our website, Data Analytics Colloquium. We would just shorten it as the DAC.
DA colloquium. Yeah.
Yeah, DA Colloquium. We can post that online, and so you can check anytime. So it's an initiative that it's kind of a collaboration between the two schools, from the UTD and National Chongqing University in Taiwan. And we try to use this kind of platform and then to convene scholars and students, and of course most of these attendees and attendants are doctor students, master students from both sides, and I think it went well. So we continue to work on this project, and hopefully all of you can benefit from all these great scholars by sharing their research, and so we can learn the up-to-date research methods in this field. So that's about it, and all the details you can find all the details on the website. So please welcome to check anytime when you're available. Okay, Carl.
All right. Allow me to do a quick introduction to our guest speaker, our inaugural speaker, Christopher Wlezien. Dr. Wlezien is the Hawk professor of political science at the University of Texas at Austin. And Dr. Wlezien is one of the most prolific and well-published scholars, and his work and appear in many top journals, and he's most renowned on his time series models, electoral models. And I should not give a spoiler, but this talk on the title on timeline of elections will be particularly important and particularly interesting also for those who are psephologists and studying elections, because and introduced to us a very important concept about the temporal dimension about elections. And I think there should be much more. I should, like a long list of his publications. I should not read it out loud, but I think allow more time without further delay, further ado, allow me to introduce Dr. Christopher Wlezien. Thank you, Chris.
Thank you for that far too kind introduction, and thank all of you for coming. Before I dive in, Carl, do I just share my PowerPoint? Is that how I should do this?
I can do that for you. Maybe you can make it easier, or you can try that if you can check out the share button, which is on upper right-hand corner, and see whether you can do the sharing. Sometimes Teams could be subject to memory overload, and it could be slow, a little bit slow. You can try share screen or share window, and you can do the sharing. If that does not work, and let me know, I can do that on my side here.
Can you see that now?
Let's wait 1 second. I do not see it yet. Does it show yet? And no, it's still not showing yet. And can you try one more time? And I have also opened your PowerPoint on my screen. If it is easier for you, I can also share that from my end. You just give me the prompt and wait to go. Yeah.
You're right. This is it's not.
Oh, it's working now. It takes a few seconds. It's working now.
Okay, fantastic. Can you all hear me? Yes? All right, good. I am delighted. Thank you. I am delighted and I'm flattered to be here. And I look forward to seeing and hearing what you all think about what I have to say tonight or this morning, depending on where you are. Like most scholars, I am involved in a number of different projects, two of which are recurring. The one I'll be talking about today, and another that develops and tests a thermostatic model of public opinion and public policy. The most recent installment of the latter project actually offers methodological innovation, but I think it relates pretty closely to developments in content analysis that a lot of other people are doing. It's that said, I think that Stuart Soroka, probably my main co-author in this work, and I are able to capture media coverage of public policy. And if you're interested in that work, please email me. I'm easy to find. There aren't many people with the name Wlezien in the world. Or you can see my website at the University of Texas at Austin. Okay. So what we have done regarding the timeline of elections is more unique, I think, and I hope. And it is what Carl and Peter originally asked me about when they reached out, was a month or two ago, about giving a talk to this colloquium. My talk today actually reflects work that's been going on for more than 20 years. First with Bob Erikson, who's now at Columbia University, at the time was my colleague at the University of Houston. And more recently with Will Jennings, who once was a graduate student of mine and others at the University of Oxford, and now is a professor at Southampton. Back in the 1990s, Bob Erikson and I noticed that we as political scientists knew a lot about what voters did on election day. And we also knew a good amount about changes that happened between elections, why the vote went up or went down. But what we didn't know really is very much about how the preferences in between elections evolved, how they come into focus. That led to this project. And It's come a long way. There's a good amount of history here, and I'll spare you a lot of the details of that history, but it is part of the talk today just because I want to show you our latest installment, which I think you might find useful, and I look forward to seeing what you think. Okay, so the timeline of elections, what is this all about? You could consider the timeline of an election. You could begin at any point, right? Since the last election, it could be the day after the last, the previous election, and we end this timeline. Imagine it ending on election day itself. Now, further imagine that over the course of this period, we have perfect readings of preferences, say aggregate voter preferences, on a regular, say daily basis. Okay, so what we want to know, and I know that's asking a lot, assuming perfect polls, but you'll see why I'm doing that. It's mostly just for theoretical reasons. What we want to know about this this time series is our voter preferences in place early, perhaps even well before the official campaign that usually attracts a lot of the attention of campaigns and news media, or do they evolve over the course of the election campaign, even longer periods of time before the official campaign or intense final campaign period begins? And what we need to know here is, one is, do preferences change? And two, do the changes last to impact the final outcome, right? The latter is important because unless changes last indefinitely, right, changes to preferences persist over time, then the only ones that would matter would be the ones that occur at the end of the campaign and don't have time to decay before the election. Voters go to the polls. So I want you to think about two things here. One is temporary bounces, changes in preferences that don't last, and permanent bumps. Although we also can imagine preferences being a combination of bounces and bumps. Here's a simple illustration of a bounce, a bump, and a combined effect, a hybrid effect. And a bounce you see here, and you could think of the x-axis just as time, and the y-axis reflecting the size of an effect, a change in preferences. And in the far left part of the frame, you could see a sharp increase and a fairly geometric decay. This is obviously a change in preferences that doesn't last. In the middle part of the frame, we could see a shift up in preferences, and it lasts, right? It persists indefinitely into the future. That's what we're going to call a bump. And then there's a hybrid effect where we see a change, a portion of which decays, and we end up at a point below the high point, but above where we started. So a portion of the effect lasts. It's a combined or hybrid effect. Turns out that this is where most of the action is. Most of the action is in the first one of these and the third, as you'll see to some extent. There's a lot of previous research bearing this out. So bumps and bounces and preferences, which is it? And so the way I think it's useful to start thinking about this is this very, very basic equation where we have preferences regressed at time t, regressed at preferences at time t minus 1. This is your simple autoregressive time series equation. Keeping in mind that these are perfect preferences, right? There's no survey error. And so that U, right, those are shocks, right? Those are, these shifts in preferences, V. And then the beta parameter gives us the persistence, right? If that beta parameter is less than 1, shocks decay, right? If the beta parameter is 1.0, shocks persist, right? So today's preferences are yesterday's preferences plus the shock, right? Tomorrow is today's preferences plus tomorrow's shock. That would be the case if it's B equals 1.0. If it's less than 1, the persistence from day to day would be imperfect, right? And the degree to which it decays would be a function of the size of that parameter. The closer it gets to 0, the shorter lived effects on preferences are, right? The less long they last. So what we really want to know here is, in time series language, is this process, these preferences, Is it stationary or is it integrated? Does it have a unit root? Or is it a combined process, right? It might be a hybrid process, as I illustrated in that figure. And here you could think about it happening in two ways, or some combination of these two ways. It may be that some shocks that affect preferences last and other ones don't, right? Other ones decay. It also may be that shocks persist for some people, but not for others, right? So some people are kind of accumulators, and other people shock are not, right? They're affected, and then the effects go away. But what this implies is a more complex equation, right? Because here you have some persisting effects that drive this moving equilibrium that goes up and down over time, and that other effects shift preferences temporarily above or below that moving equilibrium. And the way we could represent this is in this equation here. It looks a little messier, but it's really conceptually quite simple. Because basically what we have here is today's preferences are this equilibrium, right? At the previous point in time, plus the persistence of this where the preferences are above or below that equilibrium at that point in time, plus these two shocks, one of which decays. Those are the E shocks, right? And one set of shocks persists, and that's the U set of shocks. And in this equation, the beta parameter is less than 1. And so we have those E shocks affecting preferences but not lasting, the U shocks affecting preferences and lasting, forming part of this moving equilibrium V star. Is that all pretty straightforward? It's not a difficult equation, I think, but if you haven't seen it before, it might take a few moments to think about. Because we typically we oftentimes don't think of time series. Even those of us who do time series, we tend to think about it as stationary or integrated in a pure sense, not in this combined sense. Now, in theory, a combined process contains a unit root because that V star, it dominates the variance over time. Over finite time, that's over finite time. That's a little messier, and I'll spare the details of that today because this is just a theoretical equation. We all good? By the way, feel free to chime in if you have questions or comments along the way. I don't know if that's the norm in this colloquium, but if you'd like, please do. I don't want you to get lost. But this is just a theoretical setup. Okay, so that's how we started thinking about preferences, Bob and I. We were quickly encountered some realities, right? And the first is that in what we started focusing on is presidential elections in the United States. And what we found is that, even in the United States, presidential elections where we seem to have a lot of polls, you don't have a lot of years in which you have a lot of polls. And so you have these slim series with lots of missing data. You don't get anywhere near daily readings in most years. In a lot of years, you don't even have weekly readings. And you also have this problem that when you do get sequential readings, even if they're separate respondents, they oftentimes overlap the same periods, and so we really aren't getting nice clean, separate readings of preferences, even if we could separate out the respondents. And so it's just really, it's really difficult to do these kinds of analyses in a very, very meaningful way. We also found that, trying to do weekly or biweekly time series was difficult, and because there still are missing data, and there's still survey error, which complicates the analysis, right? This assumption about perfect polls just doesn't hold, as we all know. And we also lose this granularity, right? We're not able to get, weekly, biweekly, every month. This is not a very fine-grained analysis that a lot of us are looking for. Plus, as it turns out, a lot of us are not interested in these doing time series and election after election. They want to know how polls tend to come in time, come into focus over time based on a set of elections, right? Like, given the history of presidential elections, when do things come into focus? right? Given the history of congressional elections, when do things come into focus? Good, Carl?
Yes. Yeah, sure. We may have one question.
Sure.
I saw a hand. Don't worry. I will coordinate the questions. And if you are too shy to speak up, you can definitely type the question or questions on the chat box, and we will talk about. I will relay the question to the speaker. Chris, I have a question myself. So, did you mention that that missing data could be also attributed to the majoritarian system or other system that may take on different time intervals for calling an election? For example, like the British case and the Taiwan case is more like an American system. You know, the Taiwan case is almost exactly the same, except they have a little PR element in the legislature in the congressional election. So the missing data will be also attributed to different electoral systems or different party systems.
Well, yeah, there's all kinds of reasons we're going to have missing data, and we do try to in some of our more recent analyses, because we do you probably know we're doing research in a lot of different countries, like 44, 45 countries. Some
Yes.
of our analysis.
I mentioned this to the audience before you came. Yeah.
Yeah. So as you know, there's lots of variety there. We're trying to capture some of that variety in the analysis, and you'll see some of that in what I present here later on. But and we do try to take into account the calling of elections and what effects it has. We don't find a whole lot of effect, but there's a whole variety of reasons you get missing data, and it's even worse in other countries. And so if you're looking, if your point is that in some countries it's an even bigger problem than it is in the United States, you're right. That is true.
I count on you to give a little more detail to introduce your big data set. And you are so generous to make it available for download for other researchers. And please don't forget to introduce to our attendees and to our students.
You will get that once I get there, and the data is all available.
Yeah, please.
So
okay.
You're welcome. So what are the alternatives to polls on polls analysis? One way to think about this is. And so what we're thinking about here is our electoral preferences structured early, or do they come into focus late? And from a comparative perspective, relating very much to what Carl was just raising, do preferences come into focus later, say in presidential elections, than in legislative ones? Do they come into focus later in plurality systems than in proportional ones? Do they come in later for newer parties, right? Moving away from systemic characteristics and focusing on parties than, say, older ones? What can we do instead of time series analysis? And this is when Bob and I, back in 2002, in a piece that we published in the Journal of Politics, proposed this timeline method. And what we proposed is not studying time series, but study cross sections. Assess the relationship between the polls on a particular day and the vote across a bunch of elections. And so we take, say, 15 presidential elections. We assess the relationship between the final vote on election day and the polls on the day prior to the election. And then we do it again 2 days prior to the election. Then we do it again 3 days and 4 days and so on, as far back as we have data that we can use effectively and assess this relationship. And what we want to know is how strong is this relationship at each point in time, and how does that relationship, does the relationship change? And if so, how does that relationship change? And ultimately, why does that relationship change? Okay, here it is formally, right? It's just a equation for elections J, say, and I just picked the number 15. And I just picking U.S. presidential elections, as you know. I think Carl for sure knows. We're doing elections all over the place. And this is the simple equation. So we have the vote in those 15 equations J, right, regressed on this intercept at each point in time T, right? And then the polls, right, or preferences in that election J at that time T. And that's what we're trying to estimate. And we're interested in the B's, relating those preferences to polls, as it turns out, and the vote, right? And we're also interested in the United States. We started off with the R squareds because we're looking at a two-party system. But we, when moving to a comparative context, it's the root mean square errors are obviously a lot more important, and that's what we turn to when we move beyond the United States. And what the pattern of the results over the election timeline tells us a lot about the structure and the evolution of electoral preferences. Because as B approaches 1, right, and I'm sorry, there's a mistake here, and alpha, it's not actually a mistake, alpha and the root mean squared error approach 0, the polls and the vote literally match up. So if they match, if the vote and the polls are the same, A is 0, B is 1, right? And the R squared is 1, root mean squared error is 0, right?
Yeah.
Right? Okay.
Yeah.
Now, we're interested, we're not just interested in the fit, right? We really also are interested in that beta. It's really, really important, right? Because we want to know about the match. We don't want to just know, hey, there's a high R squared and the coefficient's 0.8, right? Which is possible in theory. In practice, maybe less so. Let me keep going here.
Yeah, please.
We're not done with that equation, so I'm going to come back to that, and then we're going to move beyond it because it only provides limited information about the world, and I'll tell you why. So we started off in analyzing U.S. presidential elections, and we found evidence of this equation performed better as we moved throughout the election year, but there were key, usually just improved very small, by small amounts, and then we saw big shocks during the convention season when the Republicans and the Democratic parties have their nominating conventions, and that causes preferences to move wildly in different directions typically. But we oftentimes end up in a different spot after the conventions from where we started, and that spot we end up is usually really, really close to where we end up on election day. But we get a little bit of fine tuning after those conventions as well. Yeah, Carl, go ahead.
Yeah, sorry to interrupt, and I think I promised students that I can read out the question. I think this is a question you can also address maybe later along the presentation. And these students said, I think that the path dependence that occurs in the social science field is an important issue in time series analysis. It seems to happen often, especially in elections. How can we handle this in the model? I think it's a general question. I think I leave it to you to maybe address it later along the way. I think this is a question the student raised. Yeah.
Yeah. I do want to address it now because this is not, okay, just to go back, let me just go back here. When we were in this land, right, this is a time series. That's a time series regression. And so today is a function of yesterday, right? And that's where we expect dependence. This is not. So with 15 elections, we have a matrix with polls on every day, 15 elections, right? And we have, just think of 15 elections. You could think, I don't know how you want to do this, but I would think about it as having the short vertical side of the that would be the 15 observations, and then you could have across the top, you would have the vote, polls, 365 days and before the election in each one of those elections, polls 364 days, polls 363 days, polls 362 days, and you're basically doing a regression, right, between the vote and each one of those poll variables day by day. And so the dependence is not in the estimation, right? But the dependence really, to a large degree, is revealed, right, in the pattern of the betas and the fit. Does that make sense?
Yes.
If there's no change in preferences that lasts, right, then we're not going to see any changes in the B's and the R squareds or root mean squared errors. Does that make sense?
Makes sense. Yeah, it does.
Well, see, this is really important because the whole point. Thanks for this question. I mean, this is, you know, I want you to understand what I'm saying and challenge me too. But we can't really run this regression, right? Because of these problems I'm pointing to here. And so what we're left with, and we may not even want that regression. We may want exactly the regressions that we're talking about in this timeline method, to the extent we want to say something about, you know, where are we, for instance, in this congressional midterm election by comparison with the past. Right? So with this different technology allows us to get over the problems of slim time series, erratic time series, non-independent time series, right, data, and also allows us an answer to that latter question that some people are going to be interested in. So it's not technically, you know, path dependency is not in the estimation, it's not in the model, but it is revealed in the patterns, right, that we see in the results. Peter, did you have a question? No? Okay.
I think on the other side, Peter is trying to maybe interpret this also in some layman terms and
right.
in Chinese too.
So I apologize, kind of just interrupting you because we're in the classroom right here. See, we're wearing masks. Yeah, and then somehow I can, at some point, I just try to elaborate the things that you have spoken, and then so if they have some questions, I can quickly answer it, and I will just respond to them. All right. So if I have questions, I will unmute myself and let you know.
Yeah, just chime in. I'm easy. So I'm going to give you. I could show you. Let me go ahead here. This is getting ahead into the data, but just give you an example. This is data from hundreds of parties in many countries for the last 80 years. Okay, so in the upper left-hand frame up here, this is poll data on the x-axis, right? The poll share, 900 days prior to the election, and there's the vote on the y-axis, right? And that's 900 days out. And what you can see is that there's a relationship there, right? But it's and maybe it probably, most people look at it and go, wow, that's a strong relationship. And so I think many people are surprised that we see this relationship, right? That we do. Now, but I do want to highlight for you, though, that this is a little bit deceiving, I think, because, you know, there's a bunch of parties up here that are big and they poll a lot and they get a lot of votes. And there's a bunch of parties over here that are small and they poll small and they get small, even if they bounce around a little bit from election to election. And so it's a little bit deceiving. But you can clearly see that the line and the fit really sharpen up as we go from 900 days to, 500 days to 300 days and so on. And at the end, they line up perfectly, almost. Does that make sense? So if you run the regression, you're going to get a B here of close to 1 and a root mean squared error of quite low, right? I don't know the exact. It's going to, so probably somewhere around 2. And 2 percentage points. And over here, you're going to get a coefficient below 1 and a much higher root mean squared error. Does that make sense?
Sometimes I think I mentioned to my students, sometimes this will be a situation called too good to be true scenario. But you have a lot of data. I'll let you talk.
I have a lot of data.
So good. Data so good.
You're welcome to use it. But let me go back. So, because I don't want to lose training complete. So what do we know about, we've applied this in a lot of different places. So in the United States, in presidential elections, we see some bumps. And so we see change. and we see persistence. In congressional polls, we find it's similar, but the structure is different in that it's much more, polls are more informative early, and they're less informative. So, yeah, Carl? Are you good? Okay.
Yeah, go ahead.
Yeah, so we did this U.S. stuff, we did some Canadian, some congressional stuff, we did some UK stuff. And there we find even more informative polls earlier on. And then Will Jennings and I, Will Jennings is on this paper here, this 2013 paper, and then he and I really have done a lot since that point in time. And so he and I have amassed a ton of data. I mean, tens of thousands of polls since 1942 to the present. I think we're at 47, 48 countries now. The data are available through my website, and they're archived in a number of different places. The most recent piece we published, I think, was Nature, Human Behavior, and the data are archived there because they require it. And so if you have problems, you just email me. I'm really easy to find. So in this paper, we did over 300 elections in 45 countries, and we found a general pattern of evolution, but that there's some, institutions matter as well. And that was really satisfying to us because they mattered in ways that we sort of expected, although we didn't find the effects to be as strong as or at least as pervasive as we expected. And I think that's revealed a limit to what we were doing. And I'll get to that in a moment. And so here's what we found, that polls became increasingly informative, like they did in the U.S. presidential and congressional elections and the British elections. And so and that tells us that the fit of those, the coefficient went up, the fit went up. That tells us that there are changes in preferences, and those changes, at least to some degree, are lasting, because otherwise we wouldn't observe those patterns. The process, again, as you could see in the figure I showed you, it plays out over long stretches of time. Okay, so we were wondering, so electoral institutions seem to matter. Government institutions, particularly presidential and systems, presidential elections versus legislative elections mattered. We wondered about political parties and whether they mediate the effects of institutions. We also wondered if parties have independent effects. We also wonder about the effects of elections, whether elections differ in ways that we could try to understand better. And the problem is that this kind of approach that we were using, that Will and I used, it required us to subset elections. So we'd have to say, let's go run a regression for presidential elections. Let's go run one for legislative elections. Let's run one for parliamentary legislative elections and presidential legislative elections. Let's run, and so you're having to subset these cases in order to do the analyses. And that's a real, and it was not possible to simultaneously assess the effects because of that of institutions and parties. So we could only do one institution at a time, and one type of party. And so what we did is we decided to come up with a different approach. Here's the revisit, the approach that we used in the past. And here I'm adding some more subscripts, elections J, parties K, keeping in mind that parties are country specific, and so there's country kind of built into that. And so what we did is we imputed preferences for the days, polls for the many days that were missing. And again, we looked at the fit, right, R squared and mean squared errors, and then we looked at the regression coefficients. And again, it's just as I said before, as that beta goes to 1, as A goes to 0, as the mean squared error goes to 0, the poles in the boat converge, right? And as the movements in these over time tells us about effects of the campaign. We started wondering about how to actually best encompass or encapsulate this effect of the beta, the alpha, and the mean squared error, because those are 3 statistics, and it's kind of hard to juggle those. And what we realized as we started thinking about this is the best way to encapsulate those effects is to not focus on the betas and the alphas and the root mean squared errors, but to focus on the mean absolute error. Because that's really ultimately what we're interested in, right? If the polls perfectly and the vote are the same, the mean absolute error is 0. As the polls drift away from the votes, the mean absolute error goes up. It allows a direct assessment of the match between the polls and the vote. So we made that step, and because what we found is it was easy to be seduced by looking at the R squared or root mean squared errors, to look at the betas but not the alpha, and not all three together. This provided a solution to this. But as we finished this paper, laying this out and assessing a few other methodological issues, we realized that, right at the very end of the paper, basically actually at the production stage, that this provided the basis for a broader analysis. And we could focus not on subsets of elections by looking at the mean absolute error. We could look at the difference between the votes and the polls, the absolute error, day by day, party by party, election by election. And we can include on the right-hand side a variable t capturing time. And as it turns out, we come up with a nonlinear complex way to, because that's the way it needs to be. And you could just throw in all the x and y variables you want, both additively and also interactively with time, to see whether or not there's a fixed, constant effects across the time, the election campaign, and also whether or not there's effect that changed with time, right, which would be revealed by the interaction. And this for us was a real eye-opener. And you might think, well, this is obvious. Well, that maybe we were slow to figure that out, but it, we did, and that led us to what I'm going to show you today. So what's the data? I just showed you some of the data. Remember, this is it. This is where we get it. National trial heat polls, asking about how people would vote if the election were held today. There's a variety of questions here, right? So basically, it's party support in the polls. We removed overlap in the polls, like tracking polls, right? So you don't have the same respondents. We date each poll by the mid date of the polling period, and then we pool polls by date in each election for each party, obviously. For today, I'm just going to focus on legislative elections because it reduces the moving parts, and I think it's useful given what we're doing, because I think it's a little tricky to follow. We look at the last year before election day for this analysis, because we're focusing on legislative elections. We have about 27,000 daily poll readings between 1942 and 2017. There's 231 discrete election cycles in 26 countries, and we have observations on 208 parties. The average number of parties per election is about 5. So you end up with about 1,000 observations, 1,100 observations, day by day. We can impute for the many days. There's 90% of the days for which polls are missing, and I'll tell you more about that. And then we have to have data on vote shares, and because that's you need the polls on the votes to get the error. So far, so good.
Yes.
Those are the countries. Yeah. Question.
Quick question about, you said the average number of parties of 5, so that means we still have a little bit bigger sample on the multi-party systems like in Europe and maybe other country, New Zealand. So 2-party systems are generally a little bit less represented, right?
Yeah, well, they're overwhelmed on average by the countries with 5, 6, 7.
That's true. Yeah, okay. Yeah, but they are all national elections. Yeah.
All national elections.
Okay.
We don't have to do it this way.
Yeah.
But it makes it a little bit, I think, more intuitive to just. It's not the same kind of election. This is the country. Is that countries? Um, and the kind of systems and the years we have elections. We actually are in the process of adding Taiwan. So just in case you're wondering, that's been going. We've been adding a bunch of countries. Got some additional French data. I mean, I could show if you go I'm gonna. I told. I mean, there's a bigger data set that's available to you on my website, but also it's archived. Just go find it if you want. If you have any additional, if you want any, if you have any other additional data for us, or we're missing something that you know about, just let us know. We haven't, we've missed a lot, and we keep adding. And we made a few mistakes, and we correct them when we go. But there's so much data here that it doesn't make a whole lot of difference. You add another country, you correct the data point here. It's just you'll see there's, we've got like when we do imputation, we've got almost 400,000 cases, right? It's a lot of data. Because this is not imputed; these are raw data, and we don't have every day here, right? And so, you have parties that are on missing here, but they're there. This is based on the raw data. And so that's why 900 days out, you don't have as many data points as you do the day before the election. But here you don't have all the cases because sometimes you don't have polls the day before the election. Right? In a lot of countries, in a lot of elections, you don't. Is that okay?
Yes. Good. Please keep going.
Keep going. Okay, so you see this you can see like there's a structure here, right? Looks like something's going on. But do we expect it to vary depending on government institutions, on electoral institutions, on the characteristics of political parties? As I've already hinted, they can mediate the effects of some institutions, but they can also have effects in addition, above and beyond those. And elections can matter, but we're not going to do anything with elections today. It's just going to be institutions and parties. There's some system level factors. We've already seen that presidential elections really, really matter by comparison with legislative elections. But today we're going to be focusing only on legislative elections, which simplifies things a lot. I mean, what it does, if you could think about it, you got to add the additive effect of presidents and the interactive effect, and it could condition everything, right? And so these equate, you could do the analysis, but it's just a little bit hard to present, and it's also hard to interpret. What else do we expect? Well, proportional systems. We expect proportional systems to have preferences that come in focus earlier. Why is that? Well, party centricity is one reason, right? And this is sort of classic claim, right, about proportional systems. But as Carl's been pointing out here, rightly, proportional systems have more parties, and if you have more parties, you can also have a lot more volatility, right? Which can be a countervailing or balancing effect.
Variances.
What about party characteristics? Well, party size is a big one a priori, and I mean to be honest with you, I'm kind of outlining how we did this a priori, so there's no sort of backpedaling here in this what I'm giving you. This is exactly how we set this out years ago, and we expected party size to be a big one, and there's a whole bunch of reasons why you expect party size to be a big issue here, right? And first off, there's survey error, right? The bigger the party, the more survey error you expect, right? This is just right out of the Heiss equation, right? P times 1 minus P over N, right? That gives you the variance. And so as you get closer to 50%, which is a big party, right, comparatively, the bigger the sampling error. A small party, 5 percentage points is you expect to have small sampling error. Scope, right? We expect, catch-all parties. There's reason to think catch-all parties are gonna have more fluid support than niche parties, right? And this comes right out of the literature, right? It's nothing we're really, bringing to the table for that. There's also possibly something which we just refer to, borrowing some from the literature, coefficient of proportionality, where we just expect poll errors potentially to be larger because there are more voters to get wrong. Some of these expectations predict consistent effects, right, like scope, whereas others predict different trends, like survey error. We expect survey error to go down right over time because the amount of polling goes up closer to the election, so survey error should go down. And we could directly test some of these, like party scope, right? That might have effects when controlling for size. So we could do sampling error, survey error, as you'll see. We can do scope, and we could also still include size. Other party characteristics, there's party and governments. We might expect them to be treated differently from those outside. It might be that the big parties, like the prime ministerial party, is especially the case by comparison with smaller parties. Party age, I mean, converse, this is right, older parties. Identification is more established. With probably, and this sort of predicts a consistent effect throughout the timeline, whereas party and governments, is also something that we might expect to be finding throughout. Although there might be reason to expect this to decline toward the end. Okay, so again, let's go back to this approach. So what are we going to do? We're taking this measure of absolute error, right? Remember, so that's the vote minus the poll, absolute value, right? But when we do that, what do we get? We get a log normal distribution, right? So you get this, basically it has a positive skew, right? And so the median is closer to 0 than the mean. And so you have to log it. And so what we do is we take that absolute value of the poll minus the vote. We add 1 in parentheses, and then we take the log of all of that. Right? Pretty standard kind of thing. It does a pretty good job. It looks pretty normal after you do that. Is it perfectly normal? Well, is anything perfectly normal in these kinds of things? No, but it's pretty normal. So we estimate an equation. Yeah, go ahead.
Let me interrupt.
Yeah,
Chris. Yeah, I think I want to double check with the students on the Taiwan side, because I don't know whether the students are familiar with the party the party system and party literature, particularly talking about the PR versus the SMT or two-party system, because Taiwan has been like a two-party system. I think they're very familiar about it. But for the other systems, like in Europe and other countries, are using a PR, and that could explain some kind of differences here, particularly that the positively skewed distribution Dr. Felicia is talking about, and why the log is taken is needed, and because of that that kind of variance contributed to non-normal distribution. Is the audience in Taiwan okay with that? Good. Okay. Thank you. And please proceed, Chris. And yeah.
Okay, I'll keep going. We're getting kind of close in a minute. I think we should, we're probably about 15 minutes, maybe a little bit less, because I'm probably, you'll see. I'm not going to try to go through all the results, but let me just get through this, though. Just to remind you, we have the log errors now, right? That becomes our dependent variable. These are in legislative elections, so we don't have presidential elections. It's between 1942 and 2017, so that's like 80 years almost. 231 elections, 26 countries, the final year of the election cycle. So we have about 1,100 observations. Remember, there's just about 5 parties per election. Total, we have 40,000 observations of poll vote error across all parties, elections, and countries. Okay. These massive N's allow us a very, very inclusive analysis with lots of statistical power, right? We can, when we impute, we're up at 360,000. This allows us to incorporate all the system level variables we want, all the party level variables we want, interact them with time, right? And see what the data reveal. It allows us to explicitly and flexibly, I think, estimate the effects of time, and this is how we do that. This is just a nonlinear transformation of a counter variable. So if you could think of time going 1, 2, 3, 4, 5, all the way up to 365 days before, it turns out that misrepresents what happens to poll errors over the timeline, because while they decline, they tend to decline more like, Oh gosh, the figures disappeared. Oh, here it is. There.
Mm-hmm.
I don't know how that. Yeah, for some reason this is. Can you see that?
Yes. Yes.
Okay. This is over the 900 days, right? Remember, what we're focusing on begins about here, and you could see, this looks kind of linear, but we're focusing on here. This is definitely not linear. So we need to represent that. And so how do we do it? We use this general equation, and we allow the choose the k which best fits the pattern, and it turns out that the k that's 0.001 is the one that works the best. So we just do it empirically. We don't make any assumptions. We just say, let's fit this nonlinear model, basically.
Mm-hmm.
We also could, because we have ends, we could dummy up all the parties, which we do. It's really wonderful. I mean, I think I'd like to hear what you think. I think it's really great because of the power it provides, right? It allows you to, to do all kinds of interesting things theoretically, but, the data then tell you how it works, right? It doesn't make any assumptions.
Mm-hmm.
So just to illustrate additive and interactive effects, this is the, you can think of this as an effect on the y-axis and the time, right? Early on, 365 days on election day. And here's a constant sort of additive effect. Here's an interactive effect, right? And here's a combination of the two. Keeping in mind that we expect
just a quick question, yeah. Chris. It could be a naive question. So the previous curve, I believe that you account for the distribution of the number of polls over time, because now indeed you can see that the number of polls will rise and
Yes.
get more and more. The density is also get different, and it approaches to day zero. So that, I think your approach accounts for that different densities or a different distribution of this number of polls, right?
What our right-hand side, what we do here, this is estimated together with an indicator of the sampling error. So I'm going to include a measure of the sampling error on the right-hand side.
Okay. Yeah.
I want to be. I think if you're really trying to do this in a purely statistical way, you might not want to do that. But I want to tell you, I want to see how much is sampling error explaining.
Okay. Yeah. Yeah.
So I'm going to because I want to show you that, and we're going to do that. But this is just showing you how this can work. But keeping in mind that we don't expect straight lines, we expect curved lines, right? And I've already shown you that. Okay, these are the variables. We have the timeline variable, right? It's transformed, number of days before election. Standardized 0, 1. Sampling error. This is the sampling error predicted based on the share and the ends, right? Right out of HEIS standard stuff.
The ends, yeah.
Also standardized. PR 0 if it's not, 1 if it is. You could say we should do more there. We should, but I think you'll find it interesting what we find. Effective number of parties. I think this is the right way to do that. I think you agree. Party size. That's just what we do here is the percentage of the national vote. If we do percentage of early polls before 365 days, if we use the previous national vote, it makes almost no difference. I have all the appendices on that. Party age is a long number of years since the party was founded. Niche party, there you are. I could tell you more about this if you want. This is kind of standard. I mean, we've been counseled by the experts on niche parties. Governing party, party and government or not. It's pretty easy. 0, 1, and main governing party is if it's the party of the prime minister. Okay. So what do? Start with the basics. This is kind of the first half of the analysis. We have in the first column we have all these cases, right? And all we're doing is regressing the logged errors on our timeline variable t. That's it. And you can see that it has an effect, as you'd expect. It basically implies if you back out the meaning of this and put it in terms of absolute raw error, unlogged error, it's about a 2-point decrease in poll errors over the course of the election. Okay, so what do we say? We know that some of that, as you were just saying, Carl, right? Some of that may be due to sampling error, right? That polling increases as the election gets closer. That means we have more N, right? That means we should have lower error. Sampling error should go down. So sampling error should go down. So what do we find? Yes, that's exactly right. Sampling error is an important factor here, and it slightly diminishes the effect of the T variable. But it leaves a lot still there, right? So the T variable is still positive and significant, and it only drops a small amount going when you add in sampling error. So sampling error is a pretty minor part of the story here. Do you think it's worth, I really think it's worth having these two equations, Carl and Peter. I'd like to know what you think, and everybody else too. I think it's really useful showing this, don't you? Or do you disagree?
Well, this is illuminating, particularly for graduate students. They love to see the stars.
Well, forget the stars.
And,
I'm thinking about the B here. You don't have sampling error in there, and then you do here, and it changes just a little bit. It's 9%. That's kind. I was surprised by it. I expected that coefficient to drop by a lot more, but it doesn't. So that suggests that there's something real going on to preferences that's not related just to their measurement, right? Based on the N's and the shares, right? The poll shares. Okay, so what about our system level factors? Well, let's just put in proportional representation and see what we get there. So we have some countries that are PR systems and some that are not. Does this make a difference? Remember, our expectation is in PR systems, lower error. What do we get? We get lower error. See, negative coefficients. You got to keep in mind that the dependent variable is a logged absolute error variable, so it's not super intuitive. But this is like about point a little bit less than 1% in practice. It doesn't change over time. See, it's just a fixed effect. It does not depend on timeline. So it's there and it stays there. It's independent of sampling error, obviously, which doesn't change much, and it looks independent of the timeline variable, which drops a little bit more, but not very meaningfully. Okay, so we also talked about, so one of the possibilities is that PR is, at the same time, so what's going on with PR? Well, we expect PR, right, systems to be producing potentially smaller, right, more predictable, smaller parties with more predictable vote share. It's also the case that PR is going to produce larger number of parties, and that could have an effect that's kind of the reverse of that, right? And so what do we find, interestingly, when we include in effective number of parties interacted with, additively and then interacted with time, and if we add party size additively and also interacted with time, what do we find? Well, we find that ENP doesn't have much, there's not much going on there. Although the coefficient is positive, that's kind of what we expected, right? More parties, more volatility. You can switch around more parties you can choose from. Party size, though, has this really, really big, right, positive effect, just as we expected. And guess what happens to the PR effect? It's cut in about half, right?
Yes.
And sampling error effect goes from 0.22 to 0.05.
Nothing. Yeah.
It's almost gone.
Yeah.
Party size is doing a tremendous amount of lifting, partly for the effect on, of PR, but also partly the effect of sampling error. But it's also something else, right? Because it's independent of PR, it's independent of sampling error, right? But controlled. So there's something else about being big. So what about these other party characteristics that we put in? And I'm sorry if this is not legible, but so what do I do in the first column here? I add all those other parties. It's the same variables you just saw, but I add in all these other party variables, right? So you have party age, right? Niche party, party of governments, main governing party, right? So you have all those added in. And really, the big takeaway here is if you'll notice, sampling error remains really, really low. The PR effect also remains low, as you kind of expect. It actually declines a little bit more. You still get a positive but not significant effect of EMP. And you see some of the effects that you expect down here, right? Which is kind of interesting. But I don't want to get into all that because I'm going to show you figures that are going to make it easier. Here's what happens when you put multiple imputation in. One of the most notable things when you do multiple imputation is you cut the R squared in half, which is interesting. And why that happens is, recall the way we do multiple imputation, we add in error, right? For some reason, some of these have been skipping. I'm really sorry about that. But we have missing data. This tells you how we dealt with it. But this is how we do the multiple imputation. And so we do linear interpolation plus random error. Where does the random error come from? It's the distribution based on the residuals of doing a regression of polls on country dummies, election dummies, and party dummies. You've got this remaining variance. And so we create a distribution based on that remaining variance, and then we just, we add that to the linear interpolated values. You repeat that 50 times, then employ multiple imputation. If you don't know, this is what it does. It's a little complex to describe. And so the process of doing that, you add a lot of error points, right, to your left-hand side. And so you see a big shrinkage. The effects here are, for the most part, the same. What about when you add party controls? One thing that's really interesting here is this: you see that party dummy variables, it wipes out the niche party variable because they're perfectly correlated, not everything on any of the other variables. The R squared doubles here. That tells you that, there's a bunch of stuff missing from the model, right? There's characteristics of parties that we just are not modeling very effectively. Maybe it's measurement error partly, but it's probably also more than just measurement error.
We got sample size bump up to 10 times.
I'm sorry?
The sample size bump up to 10 times because of the imputation.
Well, imputation, yeah, I know. But the thing that's interesting about it is it just doesn't make a whole lot of difference.
You do the due diligence.
Yeah, this is the standardized marginal effects of these different variables plotted. I have a figure with the unstandardized. This is, I think, more useful because it allows us to compare the effects of the different variables, and so you can see like the biggest variables here, right? Effective number of parties does have the effect that we expected. It's just not that clear from the analysis. Party H has the effect we expected. Niche party has the effect we expected. Governing party kind of has the effect, but main governing party has this bizarre kind of increase in errors as you get closer to election. What is going on there? And the same thing happens with party H. And the reason why this is happening is these effects, while independent, really estimated, right, in reality are not independent of the effects of the other variables. Each party has a value of each one of these. And so when we're modeling the effect, this is coming in addition to other effects. And I want to show you, main governing parties are typically large parties, right? And so what happens if we combine the effects of size, right, party size and governing parties? This is what we get. So what that main governing party variable is doing, it's just reducing the amount of decline in the poll errors that happens, right, to big parties. So here you have two big parties, right, one governing, one not. Here you have two small parties, one governing and one not. And so the differences between the parties, the differences between those, between the parties here and the parties here are not that big. Right? The differences are really between these two. And remember, these, in reality, all the other characteristics apply one way or another to these parties, and they're correlated, right? They're not uncorrelated. big governing parties are not niche parties. They tend to be older parties, right? We have to keep those things in mind. And so when we're estimating effects, we have to, they're not, they're in reality, they occur together, not separately. And so our interpretation of their effects has to reflect those correlations. Okay, so in sum, this methodology, I think it's informative, and I hope you agree, but I look forward to hearing what you think about the evolution of electoral preferences. It's been incorporated in a good number of studies of voter preferences, but also like election forecasting models. But I want to point out that it's not just applicable to time series where outcomes are observable, right? Sorry, it's applicable to any set of time series where outcomes are observable. So for instance, we have prediction markets, right? And we could say, okay, here's the observed reality that occurred. What were the market prices on day before that the outcomes occurred, 2 days before, 3 days before, and so on. You could do this where we have repeated measures, right, that converge on a final outcome. Football teams, league places at, after one game, after two games, after three matches, 4, 5, 6, and leading up to the final number of matches. But of course, this implementation requires a lot of cases. So what exactly do we learn about elections using this method? They become increasingly informative about the vote over time. It plays out over the long campaign, but there's a real surge at the end. That surge is partly due, but just partly due, right, to the reduction in sampling error that occurs because of the more intensive polling toward the end. It's mostly due to other stuff. It holds across a wide range of countries with a bunch of different characteristics and also a whole wide range of parties, right? But there are differences here too, right? Party size is a big factor here, but we don't fully understand what's going on there. It mostly is accounted for by these variables we've looked at, but not completely. It might be that just because the parties are bigger. A general takeaway, and I think this is something that's kind of beyond this particular analysis, but I think it's an important interpretation. When we're looking at party support in polls over time, and maybe most importantly, when we're evaluating poll performance after the fact, and there's been a lot of this, right, in recent years because of quote unquote polling failures, and these were failures, right, to some degree. But we have to bear in mind that institutional context is going to matter for our expectations, right? It's easier to poll in some contexts, right? It's easier to get it right. It's easier to get it right for some parties, right? And we need to keep in mind, and electoral context itself can vary, and that's not something that we've yet examined. And because of this, our expectations and our judgments of polls should reflect the circumstances. And with that, I'm going to say thank you, Sheshe. I think there's a different spelling in Taiwan. Yeah, is that correct?
Yes, indeed.
Okay. Thank you all.
Indeed. Wow. I think let me see if I have any questions online. I have tons of questions. I have tons of a few observations. So, but I want to yield to my co-host in Taiwan first, and to grab the first opportunity to ask questions for our speaker. Peter, do you have any students, attendees, or would like to pose a question first? Otherwise, I can.
Okay. Yeah, there are a few questions. And maybe just because the presentation is kind of fast for us, and then maybe we didn't catch up really quick. So if the question that you have been explained, then we apologize. And one of the question is that the actual, the error term. I mean, the R square. The R square measures the, the variation, right? The variations. But how is the actual number of the R squares measured? Or put it the other way, the error terms, is it big or small? Which means that how the model explained the vote. So this is the first questions I have right here. And the second one is that the total ends. I mean, the data is big, right? The total n is large, but the system level variables are, you reduce the system level variables to just a few, just like party system or the PR system. And some of the countries have small n's. It's kind of the glance of the data. It's a sheet from different country, and some of the Chris, can you show us a table that shows the data from different countries? Yeah, like this one. All right, the number of elections, for example, the column at the far right, and some of the elections is one, just like Italy, and what else? So the n, the variation of the size of the n is kind of different, and the number of polls. So the questions is, to some of the countries have small n's, and then to what extent the country context, just like what you said at the end of the takeaway, the context matters. The context matters. But this the model is used the poll data from all countries, and however different country has different contexts. So it's the issue of generalizability, right? The total n from all different countries, but different countries kind of offer different size of their n's, and then we pull them together as we reduce to a few system level variable. However, the context matters. So how do you just compromise these two issues? I'm not sure if I state the question clearly.
No, I think I understand it, and if I'm not, thank you. And I'm sorry if I went fast. I
No,
was
that's all
watching.
right. Yeah.
I was told I had an hour, and I just wanted to make sure I didn't go too far past that time. And I did want to give you something that I think is hopefully useful, like cutting edge. This is like current research. And these slides, I think there's a recording, and I'm happy to answer questions. I'm happy to send the paper. I mean, so just let me know. I have an appendices as well, as everybody does these days, and they address some of these kinds of questions, particularly these cases here were just kind of stuck, right? And so the analysis. If I tell you that if we drop the cases with small numbers, it doesn't make a difference, you would not be surprised, right? Because they matter very little to the overall data set I have here, right? We have, so it's dominated by certain countries, right? And that's unavoidable. So we're really stuck with the data we have. So can I say much about what things are like, for instance, in like Croatia? No, but we're not trying to, right? What I can say is that those if you take all of those countries, so like say less than 3 or 4 cases, elections, and you get rid of them, it makes no difference to the results. Now, the reason why that's important is that there's not something fundamentally different. When we separate those and pool them, we can't do the same kinds of analyses that we do. We can't get the same power that we have, right? We include them all. But the structure of the results is strikingly similar, particularly things like the timeline effect, the effect of party size. They're really, really dominant when we do this overall all-inclusive analysis. I hope that, I mean, if you want to follow up on that, follow up. On the R-squared one, that is what I'm just providing there is just it's kind of useful because the number of cases is this, I mean, it's the same observations on the left-hand side, right? And so what that's telling us is that we're able to account for, somewhere between 10 and 15% of the variance in the log absolute errors, right? Is that good?
Yeah.
Probably the things no, right? I mean, that leaves a lot of variance unexplained. But I'm also not surprised that there's a lot of variance unexplained, because I mean, I expect, there's a lot more to this, right? I mean, what we're trying to explain here is not elections, right? We're trying to explain the errors, and there's there's a lot of junk in polls, right? And we can't measure it, and we don't try to measure it all. And so in one sense, what this may be giving us is something that's kind of, when we put the party dummies in, I mean, when we get election-specific kind of variables in there, we might be reaching something which is kind of a theoretical, approaching a theoretical limit of sorts. Does that make sense?
Yeah, thank you. Also, I have another question. Can I?
Yeah.
Carl?
Yeah.
Go ahead, please.
Because some of our students, I'm not sure if you know, though, in Taiwan, and there's a campaign coming up at the end of the year, local campaign, local election. And actually, some of our students, they're running their campaign themselves. So one of the practical question is about how does this approach inform campaign strategies, well, in any specific country? For example, if I use this, we use this approach, and then how do we go about, do a local study with this, by using this approach? And then how does that inform campaign strategies? Can you give some implication or suggestions?
Yeah, you can do the same thing if you have the data. One of the things I think, you have to have the data, right? And so you have to have historical data to do this, right? You can't, so you'd have to have enough data to be able to say something about what happens over the course of the campaign for different parties under different systems, right? And so for that, you need to have N. And so that's important. So you have enough polls in each year for years, right? One of the things that I think is really potentially most interesting about, I mean, Taiwan in a lot of ways is very similar to the United States, my understanding is, right? But particularly at the presidential election level, these are very intensive, very, very personal, and lots of money and advertising, plowed in, which is, and so that's just been and if I'm wrong, please correct me. But one of the things that's interesting is that we don't do here that you can do is you can assess whether or not there are effects over the course of election years. And this reason I raise this is this may be relevant to the analysis of when I was saying it's a good thing to have longer stretches of time. That allows you the basis to say, okay, when you're 10 days out based on history, right? This is where this is how informative polls are, and you're 20 days out. You could say something, right? But it may be that polls are more informative today than they were 50 years ago, right? And so, but if you have the data over long stretches of time and you think that's true, you can put that on the right-hand side too, right? You could say, okay, our polls in more recent elections, let's interact them with, with time, right? And see whether or not they, well, not polls, but does the poll vote error not just vary over the course of the timeline in each election year, but does it also vary across election years, right, within countries? The closer we're getting to the present, for a whole variety of reasons. It could be because of, you could theorize its polarization. If that's the case, then you could put that on the right-hand side. Right? You could theorize its media stuff. If that's the case, you could put it on the right-hand side. You might not be sure what it is, and you may just want to control for it, just like party size. Put that on the right-hand side. Does that make sense?
Yeah, but I just, I found it fascinating because we can use this timeline and then try to match the poll with vote. So I think that's a great idea. And then, but later on, it came up to me because in Taiwan, for example, context is really important. For example, the presidential election and the the national legislative election, Congress election, and the local election, they all have different stories and contexts. And that's why all the strategies are different. And for example, some of them love to use a negative campaign and some use the positive campaign. And these are our strategies. But so I'm thinking, I'm just thinking that how do we just use this kind of approach and combine that with the actual campaign strategies. So that's what I'm thinking. So I'm not asking a question, but I'm just sharing with you that what I have in mind. That's all. Yeah.
Well, let me ask you a question. I think you're right. I mean, I think Do you expect this? This is what we find in national elections all around the world, right? So that, what do you think that if we did that in local elections all around the world, it would look the same?
I don't think so. In
I don't think
Taiwan,
so.
I wouldn't think so. Yeah.
I don't think so either. What do you, how do you
The
think?
national and the campaign, like the presidential election, the party does matter. Does matter, right? The party, but the local system, not really in Taiwan. That's not the case. Yeah.
So what would you expect? I totally agree. I think that I would expect that the effect of the late campaign to be really, really big.
Mhm.
What do you think?
Allow me to chime in first. I want
Yeah.
Peter to think about. Allow me to chime in first, Chris. This is extremely interesting, and if this studies is not exhaustive, I think it's close, very close to be exhaustive. I think this is basically a true viewing, and maybe I'm maybe exaggerated. It's quite close to the truth because you basically exhaust all the data. And number one, number two is I can look at this from two perspectives. If I am reviewing from the party system, electoral system, I can look at it all, see party matters and electoral system matters. And on the other one, which is what I primarily come from, like a more like a voting behavior, voters or voters models and voters. And I believe that the takeaway should be bigger, Chris. And and if I want to push it further, because I think the takeaway is number one, voters or general electorate is rational and they are smarter than you think when you come to aggregate. Individual voters, they may be volatile, they may be swinging, switching, but when it comes to aggregate, which is what you are presenting, they are smart, they are well informed, they are getting more and more informed too. So look at this process. And this chart is telling you that, okay, of course, this saying that the vote and poll eras is getting narrow, but look at it from the other perspective. The electorate is getting more and more informed. They're getting more, they know the situation much more from day 900, 800, 700 than at the day zero. Now, I think you may argue that the campaign effect matters too, but bear in mind that the voters are smart. The voters are not easy. If you come to the aggregate, it is not someone you can fool, and they know what they are doing. I mean, in the electorate, I want to talk about electorate, not individual voters. When it comes to electorate, so they know what they are voting for. They now, of course, the party system scholars now they see the party size matter, party age matter, effective party matters. So that is, to my perspective, could be interpreted as voters are cognitive misers. They want to take the heuristic. They want to take the big things instead of. I do not weigh 5, 10 parties. Which one is actually closer to mine? Is proximity model. But I look at a sizable or maybe a governing party or a party with the plurality. Oh, this party is doing so far so good, and it ain't broke. Why I fix it? Why I need to change it? And the change it is more riskier. So I'll take the bigger party, pick the party with more information in my cognitive system. I believe that this one I know better. I have more information of this party than others. So I'll take the easy vote and the easy heuristic that pick this party more bigger size. So this is really a testimony of the theories we have been learning since Campbell and about individual voters or voters are smart and are rational. So if you are doing the polls like we are doing individual voters, you have 40,000 electorates, right? And then you do that. So that is something also from the information theory of voting. So actually, it's all about information. The information is not snapshots. It builds, it scales. It's just built on yesterday. I am maybe 50% informed. Now I'm 51% informed. Tomorrow I'll be 56% informed. So that tells you the choice of the calculus is different because, and even though we argue that could be a long dependence, long run, and this will be changing, but also bear in mind that the information is not snapshots. So information builds and accumulates. So that explains this curve. This is really interesting. I think that is the whole story. And the big takeaway is this is the information theory of the electorate. Yeah, and then this is something. And also I want to talk about that the electorate learns over time and learns and it gets smarter and smarter. So I'm particularly amazed at that sample size. I wonder that, of course, and now you have more polls. The sample size could be bigger. There could be the variance and the sampling error. Yeah. So I was amazed at that coefficient. Can you go back to that table? The coefficient is dropping, and that is literally 0.05. Yeah, and the sampling error and is 0.05 of the full model. And so that reject my original hypothesis that hey, Chris is basically just coming out of too many votes closer to the elections. So one thing I do not know is how much we can factor in the campaign, and which is also compacting or packing all this information very intensively to do that. But we can argue that they cancel each other too. I don't know how much this is canceling. Could be the differentials of the parties' campaign funding. That may be something we can check into. I don't know where you can have the data. The differential, big party has so much more money in campaigning, and then the other party is the differentials, and that matter. And so we will sidetrack or really make a difference in turning it around the tide. But looks like the tide is not turnable. The tide is not turnable if you go that electorate, getting more and more informed. You think you can trick the electorate to switch to be giving a less informed, uninformed choice? Think about it. Individual voters maybe, but as an electorate, you can't, right? This is your conclusion to, right? This is a important conclusion. I think it's totally amazing to me. That's yeah, it's my takeaway, and yeah, maybe I can open to others attendees and to maybe criticize my critic. Yeah, but I think you can have a bigger takeaway. Many theory, many contributions to multiple theories, and if I'm seeing it right here.
Thank you.
Yeah,
I wrote all this down, and your comments as well.
Yeah, any of my students, and I think I talk about this incognito miser thing in class, and voters could be lazy and they just want to look at the obvious heuristic, just like the differentialization. And anyone in the audience would like to raise a flag or have any question or comments? Peter, how about you? Yes, and I have. Then if you don't have another question, that is a question now. For Chris. Peter, I'll let you take the next turn.
Not for now. Any questions from your side?
Looks like they are quiet. Maybe still processing. Is a lot of the models here.
Did I
Too much to process. Too much to process.
I'm sorry.
I have another one. I have a bigger one, and if you do not mind, Peter and Chris. Now, the more I think about, for example, I start from a very simple two-party system setup. Okay, you have a two-party system. Actually, you have three parties because that is the two parties. Say in the Taiwan case, they are blue and green, and Now we have a third party because those who are getting tired of all this bombardment of the information campaign. So they resort to not voting or resort to voting to uh, non-major parties and no non-green, non-blue, then I will pick that. So this is the part. How do you model this? Now I've been thinking about, particularly in a polarized situation. Taiwan is highly polarized, or like in the U.S. So voters could choose to back out or abstain, and then in that case, my guess is the remaining electorate who are committed to voting, they may be more informed because they know, and they will not change. The variance in their voting choice is getting smaller, right? So the choice is already hard boiled, and this must be the party I vote for. This must be the party I vote for. I will not switch to the other party. I will not betray it. So that explains the lowering part of the variance. Now, how the hard part is, so since these abstainers or absentees, they do not choose to vote. They gave up, or they instead choose what I call a third party, independent parties, and if the in the multi-party setup, you can see that, or they they particularly, for example, vote for in the Germany case, not the biggest party, and then we go for small parties, and just I do not know whether this could be categorized as a protest vote. So in Taiwan case particularly, and that is the case with it. Now, when it comes to the voting day, of course, they may be for tactical voting. They still go to the blue and green, but on the non-voting days, they probably will just say, hey, I do not support neither of the major party, neither of the incumbent party or the biggest opposition party. So how do we model? How do we estimate this part of the electorate? Am I throwing out a question for you to advise? Yeah, Chris.
No, this is something we thought about. We're beholden to what pollsters do, and so what they report, and so we rely on that data, and so that is a bit of that does limit this kind of analysis. Although we think about it, but when Bob and I started off on this, we would take the don't knows and we would allocate them proportionally.
Non-response.
Yeah, we would allocate them proportionally.
Yeah, but that is pretty much like quite stable, right? The non-response and or don't know. Are they?
Yeah, it goes down though. It goes down over time. Over the course of the election, it goes down. And so, so what's happening with those voters, I think, is interesting. One of the things that we struggled with is whether or not we have the power to actually say a lot about them because of the sample sizes, the amount of error variance you'd get associated with it, the survey error that's not sampling error, that's due to just surveying organizations. I mean, because if you look at these same survey organizations producing a poll on the same day, they report hugely different numbers of don't knows, and so we just don't know, like, what does that mean, and how do you deal with that? And what they do changes over time too, right? So it's not like we could say, oh, Gallup does this, and because they don't tell us really entirely what they do, and so we really trouble, even to the extent it's done right and it's done consistently over time. Does a proportionate split, like let's say 50-40, you have 10% don't knows, and if we just implicitly assume that 50%, sorry, that 10% is going to split 10%. Like 50-40, right? Or is it going to split, if it's don't know, well, maybe we expect them to split 50-50, right? Because that's what you'd expect of a coin flip, right? Those are such small differences. There's such small differences. And can you, even to the extent you could, you have the don't knows accurately measured, can you really neatly detect that kind of movement? And we were worried that we couldn't. So we didn't do a whole lot with that. I think it's much harder for us with 45 countries and 80 Poland. You know, if you have advice for that, if you have a research project, because we have data, and you wanted to try to do something with that, please let me know. I mean, because I would be willing to, try to make that work.
Yeah, quite a while back, Harold and I had a paper, electoral studies, that actually we put that non-response or don't know as a category because we found out in the Taiwan case, at one election, that proportion is about 35%. So that is something we believe we cannot just ignore and put into the missing value. Yeah. So maybe the Taiwan case, yeah.
So go ahead.
So the Taiwan case could be interesting to study, and you may next time take a look at that. That will be something we can pick on the brain and to see how that could be better model. So we have done a simple model and use a simple logic, and they say they are generally supporting the losing party, so they refuse to tell the answer because the party already lost, and also they are not necessarily like a informed voter categories like education or staying in the urban area. But it's a very not particularly a strong model, but we still can identify that kind of features of the non-response respondents. So we believe that, of course, that it's too big to ignore. It's at 35%. So I believe in Taiwan case particularly, and as some voters and could be getting tired of the blue or green parties because of a highly polarized situation, and they're getting to be too emotional and too emotionally charged in the campaigns and name calling, negative campaigns, and it's totally predominant in the Taiwan context. I think this is what Peter's questions. How does the context apply to this and to your findings? I think that could be. I don't know. Maybe the Taiwan could be something is worth your attention, and you do the study. Chris, take a look at.
Well, we are getting the Taiwan data, at least the national data. We don't know about the local data, Peter. Maybe you can help us there.
All right. Allow me to add something. Yeah, just respond to
Sure.
to Carl's comments, because Chris, you mentioned something about the polls today are more informing than those of 20 some years ago, right? Today's polls are more informing.
Well,
in general, yes, I agree. Certainly, technically, or the technical quality is getting better and better, and we try to adjust and make the adjustments. For example, the Donald Trump case, and then just after the first election, and they tried to change the method or strategy of polling, and so it's kept kind of evolving, getting better and better. I agree with that, but in Taiwan, I personally, just like Carl just said, there's certain quite high percentage of people they are reluctant to express their own opinion or their stand. So I think there are game changers here in terms of the national elections. They're really the game changers. So the either party there or both parties they try to get votes from those we call that the middle voters, right? Try to get them. And so the polls here, at least for in Taiwan's case, people are getting less and less. They don't just believe the polls though, and it becomes a strategy by either parties or the campaigns. Say, see, we're winning, or say we're winning by this margin, and it's been used by as a part of the campaign strategy instead of it's a neutral tool or instrument to measure the vote preferences. So this is a situation right here, and then I'm not sure if this is going. How does this going to change in the future? I'm not sure, but it's a general sentiment that people here do not quite believe in the polls. So I'm not sure if this affect anything or give you any idea about this, this approach.
Oh well, polls. Yeah, I mean, no, I don't disagree with you that polling organizations are attempting to try to make things better and better. I don't know if they did a very good job in going from 2016 to 2020, right? It looks like we just have a non-response problem, right, in the United States at least, and that may be true elsewhere. This reluctant expression of support is an interesting one. It's not clear that we have that here. I mean, for instance, in 2016, this relates also to Carl's question, is that 2016 was really interesting in the United States because the undecided split overwhelmingly for Trump. And the reason why that's interesting is if they're really undecided, then they shouldn't be splitting overwhelmingly either way, right? They should be just kind of randomly going one way or the other. And some people like to attribute it to things like events and the like. And what my take on it is that people were not reluctant to say that they were supporting Trump. They were reluctant to vote for Trump. And they ended up voting for him in the end. And so that was 2016. By 2020, you didn't have that issue at all. And so, people had either sorted in or out. I think a lot of the people who were wavering in 2016 just did not vote for him in 2020. And they were saying, I'm not going to vote for him. So overlaid on this, and I know this sounds like a scattershot question, but I think there's a lot of stuff going on here. Technology, it looks like in 2020, one possibility is that what's happening is that the People's Act, and this is raised by Joanna Dunaway, a colleague of mine down the street, who's been arguing that with some co-authors, that part of the explanation may be internet access, that as we go more and more to internet polling, internet access becomes important. The quality of the internet connection becomes important to whether or not you're going to want to go take the poll and finish the poll. And so, and internet access is highly correlated with urban-rural split, and that is also an important dimension of Trump support. That's an issue. Polls in the modern day, I don't know if it's the same thing true in Taiwan or not. This is a real trouble. This I think relates somewhat to both your questions. In the modern day, who's taking these polls? I mean, how many undecided voters are even taking the polls?
Yeah.
Right.
Mm-hmm.
I mean, we used to have as an incentive, if you answer correctly, and we'll give you fewer poll questions at the end, right? But I'm not so sure that's an incentive anymore for the people taking the polls. I mean, this is right. This is right. This is an unusual breed, right? It's a smaller chunk of the population. They seem to be likely voters, right? They seem to vote. They seem to, for the most part, tell us what they think. So maybe this is maybe they're not a very representative sample in a whole variety of ways of the broader population. What do you think? I mean, there aren't many undecided. Look at these polls. We have 40% of the electorate not voting, right? 35, 40%. We don't get that in the polls. You don't, right? Why not? If we're doing a good job polling, right? We should have those kind of numbers. Does that make sense?
Yes.
So
indeed. All right. I think I wish I could have another hour, but I think this is a little bit late for Chris also. So I think I'm getting to wrap up. Really like to, Chris, and I can send you some of the Taiwan data, and actually had the Taiwan I think a couple of organizations already accumulate Taiwan data for basically over 20 years now and do like elections surveys almost every year or every other year. So yeah, these are really high quality data too. Let me, if you're interested, I can send you the election study data in terms of polls, and I think I can collect some and maybe, and if you're interested, you can incorporate that, and that will be. I would love to do be your service and at your service. And all right, then in the meantime, let me see if we have more. Yeah, more questions. There's some echo here. Yeah. Okay, and Peter, do you have more questions from the Taiwan side?
Not for now. And I'm pretty sure it's quite late in their side, and see, you need more coffee to to stay
I think it's too late for that.
So
We promise to give
should,
some good
we
jokes.
should just let Chris go now, and the audience too. Yeah.
Could I quickly respond to a couple of things? I want to thank you. I hope if my responses
Sure.
have not been that, it's because I've been grading since 5 this morning and been teaching. It's been a long day and it's late. I'm sorry, but I want to thank you. I want to thank you for
Same
the
here.
offer of data. The offer of data is fantastic. I will acknowledge you, and if there's anything you want me to cite, please make that clear. I also wanted to mention, thank you, Peter, for your comments and for everybody there and their participation. But I also wanted to mention, Carl, that you raised Harold, and I just thought it was a really nice time to say that I miss him, and
Yeah.
I know you, and
Mhm.
all my best to all of you at University of Texas at Dallas.
Thank you, thank you. I have to pay tribute to Dr. Harold D. Clark, and he was the founding advisor to this colloquium, and he contributed a lot in particularly inviting scholars, speakers from all over. We have Europe, we have Asia here, and so credits. Say. All right. I thank you again, Chris, for bringing it up.
Mm-hmm.
Right. I think we can wrap up and particularly bring to your attention for next week a speech. Okay, we have one more question from a student. Kindle, go ahead.
I am so sorry. I was wiping my keyboard off and it clicked the raise hand. But now that I'm speaking, I just want to thank you for speaking. I know I didn't have much to contribute while it was going on, but I was just like absorbing it. So yeah, thank you so much. It was super informative, and I'm done.
Thank you.
Thank you, Kindle. Yeah.
If any of you have comments or questions, please feel free to email me. If you want data, let me know. It's on the website. It's also archived elsewhere, but let me know if you have issues, okay?
Yeah, and it's very generous of Dr. Wlezien and putting out the data. You want to download the whole data set and then do the analysis yourself. Okay, and anyone else? I think please check out our website, d@colloquium.com. Next week, we have Dr. Anton Sobolev, and talking a new topic and using big data to measure political phenomena. Okay, phenomena. Okay, please register to come. And if there is no other announcements, and Peter, do you have anything to announce?
No, just try to mention what you just mentioned though. Next week, at the same time, please come back and make yourself available. And thank you for joining us today. And we look forward to see you again 7 days from now. And Chris, thank you so much. Thank you so much for giving this wonderful presentation, and that's really informing. Thank you so much.
It was my pleasure. Thank you. Thank you all.
Thank you.
Thank you.
All right. Thank
Honors
you.
are ours. Yeah.
Yeah. All right. Good night
Thank you.
and good afternoon, right?
Good.
Okay.
Thank you.
Yep.
I look
hope
forward to
see
seeing you
Yeah.
and soon.
Yep. Thank you. Bye.
Bye,
Bye.
Chris. Good night. Good night. Goodbye, everyone in Taiwan. Yeah.
Okay.